here we go, please. Again, if you're in the category where you made a B and you want to make an A, then start asking me questions, more questions. All right, if you made a C, you really have to start asking me questions. Come on, you got to speak up now, all right? You got to speak up. And some of the boys especially are going too fast. Slow down. It's much better to be accurate than it is to be in a hurry. All right? So today, we taught this in 5th grade. We taught it in 6th grade. You're getting it a 3rd time in 7th grade. However, the biggest difference is we have positives and negatives now. That's it. That's all the differences. All right? So let's see if you understand what I mean. Today, what I'm going to do is I'm going to go through and do all of 1 through 10. And then if you can do 1 through 10, that'll give you a pretty good idea of the rest. All right? But I'm going to show you all 1 through 10. All right, so now the first part is it says write each number as a what? As a fraction. But to me, it looks like it's already a fraction, right? So I really feel like they should have said write it as an improper fraction. All right? So who's going to tell me how to write that, or who remembers how to write that as an improper fraction? That would be what? Ooh, tell me. Yes, 15 over 4. Because again, to write it, remember, here's what you do. Remember, you multiply these two things together, and then you add. That's exactly what it was. So it's 4 times 3 is 12. 12 plus 3 is 15. So you're writing that as an improper fraction, which is just 15 over 4. If the number can be written as a fraction in that format, it's considered rational. All right, rational is just a fancy word for, guess what? Fraction. All right, rational just means fraction. If it can be written as a fraction, it's rational. Yes, sir. All right, so for question number 2, if I had to write that as a fraction, we would just say that's what? Yes, exactly. Now, in this case, though, you got to be careful. Don't forget the negative, right? Negative 9 over 1. Right, there's no decimal here.
Oh.
True? Yeah. No, there's no decimal. So it's just 9 over 1. What? No. Because that would make it a positive, because 2 negatives make a positive. You with me on this? Question. Very good question. Okay, so let's review. If I said to you 0.9, what's that? That's 9 over 10. Exactly. You with me? That's 9/10. This is just the whole number 9. Whole numbers can be written as a fraction if you just put it over 1. Because that's just 9 divided by 1. Good question. Thank you. Somebody else? What? Come on, guys. What? Yes, 9 over 10 is not 9. You agree with me? 9 over 1 is 9. 9 over 10 is 0.9. That's the difference. 9 over 10 is 0.9. 9 over 1 is 9. Come on, these are good questions now. You understand me, right? All right. So Tucker, write that. That would be what? Yes, negative 7 over 4. All right. 4 times 1 plus 3, 7 over 4. It's not 4 times negative 1. All right, it's not 4 times negative 1. All right, this is just saying the number itself is negative. So the fraction must be negative. What? That means I'm wrong. That's what you're telling me. That just means, wow, how? That's what I'm trying to tell you. I'm never going to be wrong up here, ever. Jack, listen, I'm proud of your score, 88, almost an A, right? You should be making an A now. Or I appreciate your questions. I think the most important thing for you is to say, I thought the answer was 3/4. If you were paying attention, I told you exactly how to do that. What did I tell you to do, Jack?
You said tons of other
That's exactly right. So what's 4 times 1? Plus 3. There you go. Come on, you understand what I'm saying, right? Now, I'm going to tell you, I was just kidding about always being right. There's going to be a time where I'm going to make a mistake and we should write it down. All right? But seriously, fractions, I'm a master of fractions. All right? If I write it up there on the board, it's probably right. 99.9% of the time, it's going to be right. You hear me? I want you to say, hey, what did I do that messed that problem up? But more importantly, I want you to listen to what I'm telling you, then you won't be confused. Right, Connor?
Right.
Listen, and you won't be confused. Go.
Will there ever be a scenario where denominator will change?
No. Unless you reduce the fraction. All right? That was a good question. Thank you. Very good. All right. You good? Come on now. All right. Some of you are wanting the game better. All right? The only way you can get better is by asking. All right? And Jack, you understood what I was saying, right? You understand. I don't want you mad at me. But I want you to listen to what I'm saying and apply what I'm saying to the problems, and you'll always be right, like me. All right. Here we go. That's why they have that up there on this wall, Mr. Right. All right, here we go. Somebody tell me about 0.07 as a fraction. 0.07. Oh, here we go. 7 over 100. Brilliant. 7 over 100. Now's the time to speak up if you don't know why it's 7 over 100. Why?
Isn't it whenever it's point something, is it always going to be over?
Yes. If there are 3 decimal places, it's going to be over what? Yeah. 1 decimal place, that's 10. Come on, guys. We know this. We know this. You good? All right. So 7 over 100. Now, you got to think back to last Tuesday to get this correct. And Sean has that great memory. He's going to tell me what this fraction is. Listen to him. Go ahead. Huh? Huh is not an answer, Sean. I said, what's the answer to number 5? You got to think back all the way to Tuesday. And because you were listening so closely on Tuesday, I'm confident that you can tell me what this answer is. What is it? Fill them in, Gray. No. Well, I just asked you, and you were like, Now all of a sudden I go over here to Gray, and you're wanting to pop in on the answer. What is the answer, Sean? This is what I was asking you about 45 seconds ago. You tell me you didn't know. Now I go to someone else to get the answer. Now you tell me the answer. What kind of sense is that making? Sean, what is the answer? Shh. Oh, that was so close. That really was close. Tell us. Shh. He said 3 and 85 repeated over 99.
He said negative.
Hey, I'm not negative. I'm not there. You're not in the. Don't correct me. I promise you I'm right. All right? You did not say it correctly. All right? I promise you didn't say it correctly. What?
Is it 385 over 100?
No. Tell us. He only said 1. It's not. So, Sean, tell us the answer again. Yes, thank you. He said 85 repeated. The 85 is not being repeated. When you put it over 99, the repeated sign goes away. So now, listen up, please. Anytime you have repeated numbers, there's a pattern. Oh, what?
How can we fix that?
Because we talked about it last Tuesday. These are the patterns to math. Hurry up. These are patterns in math. If something is repeated, it's over 9. If there's 2 numbers repeated, it's over, guess what? If it's 3 numbers repeated, it's over. Wow, that's from last Tuesday. Because Sean was paying attention, he remembered that. If he wasn't paying attention, he probably wouldn't have remembered it. Although he had to interrupt me when he said he didn't know from somebody else who was trying to answer the problem. But that's a different story. All right? So the answer is negative 3 and 85 over 99. Everybody put that down. All right? Repeated numbers are over 9 or over 99. All right? So now I'm going to slide over and you can tell me, someone, please tell me about point. Somebody tell me about 0.78 repeated. Sienna, thank you. Go. You have not been listening one little bit. 78 over what again? Look back at the previous problem. 78 over what? 78 over what? Look at the previous problem. 99. Yes, because there's two numbers that repeat, so you put it over 99. That's the rule. And pretty soon when I ask you to bring your calculators, we can do 78 divided by 99, and it's going to come up to be what? 0.78 repeated. All right? So I want everybody to put down 78 over 99, and then I want someone to tell me what the problem is with 78 over 99, Jack. Sean knows now. Simplify. Thank you, Sean. Divide by 3. Wow. This is what I keep fussing with you about. Now, don't be in a rush, but give me the right answer. Don't say it incorrectly now. Wow. Oh, start with the easy one. That's a good one, Sean. So let's do that. 33. Now I need you to divide 78 by 3. 26. Good job, Sean. 26. Because if I divide that by 3, 3 goes into 7, 2 with 1 left over. And then 3 goes into 18 6 times. So it's 26 over 33. Max, are you with me? Remember what I told you. Speak up now, please. If you're not sure about something, get in the game. You hear me? Speak up. I haven't heard your voice all year. All right, I want you to speak up. All right, you're not that shy. I see you out in the hallway screaming all the time and carrying on like a wild man.
Like when you're in this Bragdon's room.
Oh, really? You're a wild man up in Miss Bragdon's room, huh?
That was one time.
Okay, one time. All right, so get involved in math class. Speak up. The worst you can be is wrong. All right, everyone in here has been wrong except who?
You.
Thank you. All right, music to my ears. All right, so here we go. I want 2 and 0.54 written as a mixed number, girls. Who's going to be brave? Thank you. What? Say it louder. Yeah, see? Good job. Just trying to scare you. 2 and 54 over 100. The reason it's over 100 is because it's not repeated this time. There's 2 decimals. Now the only thing we have to do, Miss Andrews, is simplify. Thank you. And that goes to?
27 over 50.
You are amazing. 2 and 27 over 50. Max, is that correct? Did she say something right up here? Did the girl say something right?
No.
Yes. Okay. Yes. Not you, Tucker. Not you, Tucker. We've heard lots from you. All right? We're wanting Max to talk. All right, so here we go. Now, again, I can't give you the answers to 8, 9, and 10 because I haven't gone through all the numbers for you. Now, last year, you guys should have talked about the different types of numbers. All right? Now, we classify numbers. There's usually 5 or 6 different classifications for numbers. Gray, you with me? All right? I'm up here on the board. I'm not sure what's on the iPad. All right. Thank you. Sorry. All right. So here we go. I need everybody to write. These are the notes for today. All right. Everybody has to know the different classification of numbers. And they call these classifications different sets. All right. So the first set we're going to talk about is natural numbers. Does anybody remember what natural numbers start with? Thank you, Jack. Do I remember? Yes, they start with positive numbers. That is correct. What's the first positive number? 1. So we're going to do, very good, Jack. 1, 2, 3, ... Now, what do the ... mean?
4, 5, 6, 7, 8, 9.
It goes on forever. All right, so natural numbers start at 1. All right. Now, I'm not asking you to write natural number. I'm going to ask you to abbreviate. What would be a good letter to abbreviate with? N. Very good. Good job.
Could the P also?
No, because these aren't the only positives. You'll see in a minute. All right? Hey, I'm Tucker, seriously, I'm not interested in that. Okay? Keep your... All right? Now, natural number. After natural numbers, we have what's referred to as whole numbers. All right? Now, whole numbers start with what number? Connor. No, that would be a natural number. Whole numbers start with 0. Whoever said that, brilliant. 0, 1, 2, ... The only difference between a natural number and a whole number is the number what? 0. That's it. All right, that's it. Anybody have any questions with that? And what is the abbreviation for whole number? W. Beautiful. All right, you guys are brilliant. Okay? Next, after we break them down into natural, whole, now we introduce what we talked about last week. What did we talk about last week? What numbers? Which were called what? There was a special name for them. Say it. The word we use. We're adding and subtracting what? Multiplying and dividing. Say it. Integers. Thank you very much. So I want everybody to write down the word integer. Integers. All right? They are ... -2, -1, 0, 1, 2, ... So integers are just positive and negative whole numbers. Everybody with me on this now? All right? So integers is the first time that they introduce what type of numbers? Negative numbers. All right? And if n is natural and w is whole, obviously integers would be what letter? Very, very good. Z. Very good, guys. Integers are abbreviated with a Z. All right? That was obvious. I'm sorry some of you didn't see it. That was a little obvious. Integers are abbreviated with Z. All right? Part of the reason why we don't abbreviate with an I, because when you get to advanced math, algebra 2, they'll introduce imaginary numbers. And imaginary numbers are the letter I. Believe it or not all numbers are real. There are imaginary numbers. All right? Yes, I can tell you're excited about getting to algebra 2 when we start learning about imaginary numbers. That is correct. All right. So now, someone said in the last class, yes, instead of calling them integers, we should call them zintegers. Yes. So Z, if you want to abbreviate, and let's say you forget the letters. If you forget the letters, then you have to write the what? You have to write the word. You have to write the entire word integer. All right? Now, after integers, there are called rational numbers. And for rational numbers, I want everybody to write down, if you are a rational number, don't mess around. All right? If you are a rational number, the definition is this. Any number that can be written as a fraction. Again, you're supposed to write this down. Rational number. Any number that can be written as a fraction is considered rational. Any number that can be written as a rational number is, or any number that can be written as a fraction is rational. I like what you're thinking. Let me get to that. All right? Not every number is rational. But you're close. You're close. All right? I like your thought. All right, one more time. Rational number is any number that can be written as a fraction. All right? 0 can be written as a fraction, believe it or not. 0 over 1, 0 over 2, 0 over 3. Anything with, when you divide by any number, 0 divided by any number. 0 over, I'm asking you to write it as a fraction. 0 can be written as 0 over 1. Just like the number 7 can be written as 7 over 1 or 14 over 2. All right, it can be written over anything. Pay attention. What?
I forgot to ask this question for integers. Does it only start at 2 or is it just all day?
That's what those dots are for. That means it goes on forever. All right? So rational number is any number that can be written as a fraction. Obviously, if you want to abbreviate rational number, then we would call it what letter? Obviously. Thank you. Q. Very good. Q. Obviously. All right. Obviously. All right. Now, the reason why we don't call it R is because these are real numbers. All right. So there are different letters. All right. That different words that share the same letter. So it's kind of hard. All right. So for whatever reason, I have no idea. Here's how they decided to abbreviate. All right. Q is considered rational. All right. Now, Gray said something pretty important. He said, aren't all numbers rational? No. Right? There are numbers that are called irrational. And irrational numbers, someone tell me the definition of irrational. Go ahead, Tucker. Say it. That is exactly correct. If you are irrational, you are not able to be written as a fraction. Any number that cannot be written as a fraction is considered irrational. Now I'm going to give you some examples of irrational. All right? Yes, again, it's the same as rational except not. Any number, all right, that cannot be written as a fraction is considered irrational. One more time. Any number that cannot be written as a fraction is considered irrational. We're going to talk about the abbreviation here in a minute. What? You just play around too much. I'm about ready to toss you out of class. Or I'm not messing around.
I don't understand irrational.
Are you having trouble with the X definition? It can be written as a fraction, or it can't be written as a fraction. Rational can be written as a fraction. Irrational cannot be written as a fraction. And I'm going to give you some examples of now things that cannot be written as a fraction. All right? Here we go. The most famous irrational number. Anybody tell me what the most famous irrational number is? 0 is rational. 0 over 1. What? Irrational numbers.
Pi.
Yay, pi is an irrational number. Pi has been carried out to millions of decimal places, and they've looked at the decimal place and they tried to find patterns. And guess what? There are no patterns. And because there is no pattern, there is no way to write it as a fraction. All right? So decimals, if they repeat, can be written as a rational number. If there is no pattern and the fraction does not terminate, then it's considered irrational. Now let me give you another example of an irrational. Euler's number. Soon in Algebra 2, you will talk about E. E is like pi. It's an irrational number. All right? It is an irrational number. All right. Listen, guys. I'm telling you, I'm expecting more from 7th grade. All right? You are big enough now to sit and take some notes without the wisecracks and messing around and being silly. You hear me? Seriously. All right? You are holding me up, and you're going to have much more homework now because I have to keep calming you down a little bit. Just copy the notes down. Let's get on our way. All right? Now, another example would be something like the square root of 10. All right? The square root of 10. If you type that on your calculator and hit square root of 10, it will be some decimal that doesn't repeat. All right? That is considered irrational. All right? Now, the last set. Oh, and by the way, the abbreviation, believe it or not, is IR for irrational. Yeah, I know. It doesn't make any sense to me either, guys. All right. Now, the last one is the real numbers. All right. Now, believe it or not, every single number here is a what? Is a real number. And I already talked to you a few minutes ago about imaginary numbers. When you get to Algebra 2, they'll separate the two sets of numbers into imaginary and reals. Right now, the only numbers we know about are the what? Real numbers. We don't know anything about imaginaries. In the future, you will, but right now, you only know about the real numbers. So right now, real numbers are just what? All of the numbers. All right? Any number that you can say is called a real number. All right? Now watch how you abbreviate reals. That's the reals. All right, so to make that symbol, you just write a line, another line, and then you make a big R over it. Yep, it kind of looks like pi. You're right. All right. So now that, say that.
It looks like a regular.
Mm-hmm. Yeah. All right, now here we go. Now I want to go back to identifying the sets. All right, now we're looking at question number 8. We're going to use the abbreviations. First of all, is negative 632 natural? No. Is it a whole number? Is it a whole number?
No.
You guys got to think for yourselves. You heard somebody say yes, so everybody said yes, yes, yes. Whole numbers, are they negatives? No. So is it a whole number? No, it's not. Is it an integer?
Yes.
Yes, because it's negative. So we put down Z. All right? Now, can it be made a fraction?
Yes.
Yes, you can put it over 1. So it's a rational. So we put down Q. Is it irrational?
No.
No, it is not. That's exactly smart, Jack. If it's rational, it can't be irrational. It can't be both rational and irrational. All right, and is it real? Yes. So those are what you're going to write down. Okay? All right, number 9. Is that a fraction? Can I write that as a fraction? 0.56 repeated. Can that be a fraction? Yes. So we know it is what? Rational. And if it's rational, it's also real. Now notice I skipped the other ones. I skipped the other ones because there was decimals involved. The first 3, no decimals are involved. What?
For the real numbers, what's a whole symbol?
Star. Okay. All right, 21 now. Here we go for 21. All right, is 21 a natural number?
Yes.
Yes. Is it a whole number? Yes. Is it an integer?
Yes.
Yes. Is it rational?
Yes.
Yes. Is it irrational? Is it a real?
Yes.
There you have it, guys. That wasn't bad. All right, let's move forward now, guys. All right, here we go. For number 11. All right, I need some help writing this as a fraction. Max, tell me 1 5/6 can be written as what? How did you get that? Thank you. Don't be sorry, Max. All right? I'm trying to get you in the game, okay? 11 over 6. Don't worry about it. 11 over 6. Perfect. What? Thank you. Anybody else? See, guys, look how much work we have now. All right? Number 13. That's going to be what?
Negative 12 over 1.
Okay, that was number 12. Thank you. So 13 was what? Say. Thank you. Negative 87 over 8. All right. Now let's check out 15, please. What about 14, Connor? You're right, because I'm supposed to be doing the what? Odds. I'm doing the odds with you. She just accidentally gave me the even. It wasn't a big deal. All right? Just go with me. All right? Just go with me. All right? 3.625. Somebody tell me what fraction that is. Come on, go.
3.625 over
Now, how many decimal places are there? So you, now, yes, 1,000. All right. The number of zeros corresponds to the number of places after the decimal. So that's the same as 3 and 625 over 1,000. Now, I have to reduce that. That's the annoying part. So if I reduce that by 5, I'm going to get 3 and 125 over 200. And then I can reduce by 5 again. So it's going to be 3 and 25 over 40. Then I'm going to have to reduce it by 5 again, which becomes 3 and 5/8. Okay? So let's take a look at 17. So somebody tell me what this one is. Xavier, what's 17? And? Good, but I know you meant 36. And then I reduce the fraction. All right, so what does that reduce to? Good, so it'd be -5. And now what do I reduce to by again? 18 over 50 reduces to what? Come on. No. They're both even. Divide by 2. So what do I get? There you go, guys. All right. Really? Shh, shh, I'm listening. Go ahead. Divided by 3. Yep. And then where you get on the bottom? All right, here we go. 19. -1 3/10. Tell us. Yes, very good. Equals -1 3/10. All right, so again, guys, you can see how I wish I would have gotten to more done, but that's part of because I had to tell some of you guys, come on, relax, let me teach, right? I don't want to do that. All right, I want to get through as much homework as I possibly can. That means you have less, not more. Tucker, you hear me?
Yes.
Jensen, you understand me, right? Come on, I don't want any trouble, okay? No reason for it. All right, so your job tonight is to go ahead and finish everything 1 through what?
36.
1 through 36. The bell should ring here shortly, right? All right.